4 states of a file. A folder of scout reports, well tests, and production spreadsheets goes in, and a queryable well database comes out. The extraction is the easy half. What makes this catalog trustworthy is how precisely it accounts for the files that did not make it. Every question anyone asks a document pipeline comes down to one thing. Did this file's contents actually reach the database? Most systems answer with a percentage, which hides all the interesting cases. This one answers with exactly 4 states, and it refuses to collapse them, because each has a different repair. Loaded means rows exist in the production tables carrying this file's identifier. Staged means it is extracted and waiting for the next promote. Held means it stopped at a named gate, and it will move the moment that gate is satisfied. And nothing means it is not anywhere at all. That last one is the only state that is actually a failure. Held is recoverable. Discarded is not. That single distinction drives every design decision that follows. Stage 1. You point the pipeline at a folder, it walks it, and every file gets an inventory identifier, a hash of its full path. That identifier is the thread running through everything that follows. It is how a row in a well table, months later, can still name the PDF it came from. The run is scoped to the folder you gave it, not to the whole backlog. That sounds obvious, and it was not. For a long time only the crawl respected the path you typed, and every later stage quietly processed the entire pending queue, so a run aimed at a document folder would wander off and parse well logs somewhere else. On screen here, 101 files in, 101 cataloged, nothing pending. 80 PDFs, 11 spreadsheets, 10 Word documents, each taking a different route to the same destination. Stage 2. Extraction never writes to the production tables. It writes to a parallel set of staging mirrors, one per destination, each row carrying the identifier of the file that produced it. A single scout report might drop casing intervals in one mirror, a stimulation record in another, and monthly volumes in a third. Splitting extraction from loading is what makes the next step reviewable. Nothing has been committed to the database of record yet, so a bad parse is still cheap to throw away. Stage 3. Promotion lifts rows out of the mirrors and into the production tables. It is insert only, and it will not overwrite. Whichever load gets a row in first owns it, permanently. That gives every value a traceable origin instead of a last writer wins mess. And it is gated. A well header with no surface coordinate does not get promoted. It is held, in place, with the reason recorded. The system will happily fill that coordinate in later from a reference master of roughly 4 million agency well headers, and at that point the row promotes on its own. What it will never do is invent one. Because a confident wrong coordinate plots, exports, and gets quoted in a meeting. A missing one is visible. Wrong is worse than missing. Stage 4, and this is the part that trips up every report ever written against this catalog. Promotion moves rows. A promoted row is deleted from the mirror on its way into production. The mirror is a drain, not a ledger. Which means an empty staging table after a successful load is not a sign that nothing happened. It is the signature of everything having worked. Ask a mirror whether a file produced any rows, and a completely successful load answers no. So the honest question gets asked of the destination instead. You trace the identifier forward, into the production tables. In this run the well header mirror is completely empty, and that is exactly what 99 promoted files are supposed to look like. 44 rows remain staged across 5 mirrors, and every one of them is attributable to a specific file. Now, review. Browse the catalog and every file carries its state. Filter down to the ones that stopped short, and the list comes back with 2 out of 101. Both are documents that parsed perfectly well but never identified their well. Between them, they are holding all 44 staged rows. They are not errors, and they are not lost. They are waiting on one human decision. Which well is this? Make that call in the workbench, and their rows promote on the very next pass. 11 files in this corpus were rejected on review. Scanned images with no text layer, documents naming no well, and a couple that were genuinely malformed. Each one carries the reason a person gave, and who gave it. Rejecting a file does two things. It retires the file rather than deleting it, so the catalog keeps its history and the file stops being retried forever. And it cascades to every row that file had already staged, sweeping the mirrors so nothing is left orphaned behind a parent that no longer exists. Rows already promoted into production are deliberately left alone. They belong to whichever load inserted them, and pulling them back out is a separate decision that a human makes on purpose. And this is what it was all for. Wells that arrived as prose inside a PDF are now rows, with coordinates, operators, and status. Selectable, exportable, and sitting on a map beside a 4 million header reference layer for context. Every one of them can still name the document it came from. That is the thread the inventory identifier has been carrying since the crawl. So, the scorecard, read honestly. 101 documents went in. 99 reached the database. 2 are holding, each on a stated question a person can answer in seconds. 11 more were refused on the way in, with reasons attached. Nothing is unaccounted for, and nothing was guessed at to make a number look better. That is the whole argument. A pipeline that reports 100% by quietly inventing the difference is worse than useless, because you find out years later, in front of a client. This one would rather tell you it is holding 2 files.